Welcome to the deep dive. It's pretty amazing how much AI assistants are part of our conversations now. But, have you ever had that moment, that frustration when a general AI just can't quite handle that really specific thing you need it to do?
Mhm.
The tasks we're getting it right isn't just nice, it's, well, critical. Those big off-the-shelf models are impressive, sure, but sometimes they just miss the mark when you really need that pinpoint accuracy and reliability.
Yeah, you've really hit on something important there. I mean, the flexibility of general AI is, well, it's captivating, no doubt. But when you're talking about tasks with real consequences, like financial stuff, legal things, or even just keeping customer trust, that's where you need a different kind of AI, something with, more control built in.
Exactly. And that's what we're digging into today, graphite. One of you, a listener, sent over some really interesting pieces on AI agent frameworks, and you mentioned wanting to understand how to build these more specialized AI solutions without getting totally lost in the weeds.
Mhm.
So think of this as our detailed look at a concrete answer, Graphite. It's a new open source framework designed specifically for building what they call domain-specific AI assistants.
Yeah, what's really interesting about graphite, I think, is its core idea. It totally gets the power of LLMs, but it also sees that using them effectively for, specific real-world problems often needs a more structured approach. It's not just about having a smart AI, it's about giving that AI clear rules and a solid place to work within.
Okay, let's unpack that because I bet a question popping up for some listeners is another AI framework. Seriously,
Yeah.
we've got ChatGPT, Claude, all these agent platforms. Why another one?
Oh, absolutely. This is a
Yeah.
totally fair question. And the graphic creators, they address this head on. They talk about what they see as a real gap in solving real world problems with AI tools, especially for those mission critical tasks. Think about like processing sensitive financial data or
Mhm.
helping with important healthcare decisions or navigating complex legal stuff. That's where the generic agents can, well, stumble, where even a small mistake can have pretty big consequences.
So Graphite is trying to fill that gap with a different kind of structure.
Exactly. They really emphasize that graphite provides a straightforward and controllable framework for building these specific workflows. The key difference is that it lets LLMs do more than just reason and plan freely. It makes them operate within a defined, auditable, and easily restorable workflow.
Ah.
And that last part, auditable and restorable, that really highlights the kind of dependability they're aiming for. Imagine, banks needing proof of compliance or doctors needing to review AI diagnostic steps. Graphite offers a level of accountability you often don't get with the more general systems.
Right. It sounds like they're not just, throwing an LM out there and hoping for the best. They're building a real structure around it. And it seems like they've thought about some key problems right from the start, mentioning features like observability, idempotency, and auditability out of the box. We definitely need to get into what those mean practically.
For sure. But first, let's look at how this framework is actually built. They use a great analogy. Lego bricks. Graphite has this three-layer model: assistants, nodes, and tools. So think of the whole AI project as your finished Lego model that's the assistant.
Okay.
Then you have specific, purpose-built Lego bricks doing particular jobs. Those are the nodes.
Right.
And finally, the basic little Lego pieces you use to build those specialized bricks. Those are the tools.
Okay, I like the Lego analogy. Makes sense. So let's break down the layers. What's the main job of the assistant?
The assistant is basically the project manager. It orchestrates the whole workflow, keeps track of the conversation state, knows where everything is in the process, and what needs to happen next. It's the overall director.
Got it. The central command. And then nodes. What do they do?
Nodes are the workers. Each node does one specific thing. Might call an LLM, maybe to pull info out of text or write a response, or it could run a specific piece of code like a Python function. So each node is like a self-contained unit doing one particular job.
Okay, that's clear. So you could have a node getting user input, another sending it to an LLM, and maybe another taking the LLM's output to talk to an API or something.
Exactly. And the final layer is tools. What are those?
Tools sound like the really basic action units, like the things the nodes use to get stuff done.
Precisely. They call them pure functions. Think of them as the most fundamental actions the AI can take. They actually do the specific task, maybe an API call, writing to a database, running a Python function for a calculation. The key thing is they're self-contained. They do their job without messing up other things unexpectedly.
Ah, okay.
Think of it like ordering food. You, the node, tell the waiter, who's kind of like this command object we'll touch on,
Hmm.
what you want. Then the kitchen staff, the handler, actually makes it. It keeps things organized.
So in our gym example later, a tool might be the actual code that puts the user's details into the gym's database?
Perfect example. Now, besides these layers, Graphite uses some really smart architectural patterns for reliability. One is the event sourcing pattern. What's cool here is that every single state change, an assistant starting, a node doing its thing, a tool getting called, succeeding or failing it, all generates an event, and these events are all recorded and stored.
Interesting. You mentioned auditability earlier. How does this event sourcing help with that? So it's like having this complete unchangeable log of everything the AI assistant does.
Exactly. It creates this single source of truth for the system's history. Another pattern is the command pattern. This is a neat way to separate the thing that asks for an action from the thing that does the action. They use command objects and handlers. So a node creates a command object with instructions for a tool, and a handler picks it up and executes it. Makes tool use really tidy and self-contained.
Sounds like it adds a good layer of organization, makes managing all the moving parts easier.
Definitely. And then there's the actual workflow orchestration. How do the nodes talk to each other?
Right.
Graphite uses a pub-sub pattern, publish subscribe, with an internal message queue. So when a node finishes, it publishes an event to a specific topic. And any other nodes interested in that event subscribe to that topic and react.
So it's a very decoupled way to communicate. Nodes don't need to know about each other directly, just about the events flying around.
Right.
That sounds great for modularity, but could it get complicated trying to track all those events in a big system?
That's a good point. And yeah, while PubSub is great for flexibility, you absolutely need good observability tools, which Graphite does include, to track that event flow and understand what's happening overall, especially in complex workflows. It's about having the right tools to manage that complexity.
Right.
But that decoupling is what gives you that plug-and-play modularity they talk about. You can build complex workflows by just adding or removing nodes and connecting them via topics. And if one node messes up because they're not tightly linked, it's much easier to isolate the problem without the whole system crashing down.
That sounds super useful for building AI that's, both strong and easier to fix.
Okay, so we've got the architecture assistants, nodes, tools, Lego style, all linked by events and PubSub. Now let's get into those key features they mentioned that make Graphite different. That simple 3-layer model, the PubSub orchestration, and events as the single source of truth. How do these lead to those production-ready reliability features?
Well, yeah, those core designs really enable those key capabilities. Let's start with observability. Because everything runs on events, and every state change is recorded, it's way easier to see what's happening moment to moment. Graphite uses logging and tracing, built right on that event system, letting you pinpoint bottlenecks or errors in real time. Super critical for complex AI with lots of steps and data sources. Makes total sense. If every action leaves a trace, you have a detailed map to follow when things go wrong. What about idempotency? That word might be new for some folks.
Yeah, it's a bit technical, but really important. Think of it like pressing an elevator button. Pressing it once or 5 times, the result is the same. The elevator is called, right?
Okay, yeah.
So in asynchronous workflows, like in AI, you often have to retry things if there's a network glitch or something. Idempotency means doing the operation multiple times with the same input has the exact same effect as doing it just once. Graphite is built with this in mind, so it prevents messing up data, like creating duplicate entries, during those retries.
Yeah.
Especially with that PubSub system, even if a message gets resent, the system handles it okay.
So it ensures that even with hiccups, the end result is correct and consistent. Sounds absolutely vital for reliable stuff. Okay, next. Auditability. This seems pretty straightforward given the events as the source of truth idea.
Exactly. Since every single step and decision path is logged as an event automatically, Graphite basically gives you an audit trail for free. Hugely valuable in regulated fields where you have to show compliance and keep clear records. Plus, it's a massive help for debugging because you can trace the exact sequence of events that led to a problem. You see what happened and why, step by step.
Right, like for those banks or healthcare providers you mentioned, real accountability. So you get that complete step-by-step record. And finally, restorability. This sounds like recovering from failures gracefully. How does Graphite manage that?
Right. Long AI tasks can eat up a lot of processing power. If they fail halfway through, that's a lot of wasted time and effort. Graphite uses checkpoints and that event history. So workflows can pick up right where they left off after an interruption instead of starting all over.
Oh.
Minimizes downtime, saves resources. Super helpful for those really big, complex AI jobs like processing huge data sets.
Yeah.
If it fails midway, you don't lose everything, you just resume.
Okay, these four: observability, idempotency, auditability, restorability, they really paint a picture of a framework built for serious, reliable AI, not just quick experiments. Now, to make this all concrete, the article uses a practical example: a Know Your Client or KYC assistant for gym registration. Can you walk us through how Graphite works in that scenario?
Yeah, absolutely. And they keep the example pretty simple on purpose, just to show the basics clearly. The main goal is a user needs to give their full name and email to sign up for the gym. If they miss one, the assistant needs to pause and ask for the missing info.
Okay, super common use case. What Graphite parts do they use?
So they define 7 topics for the communication flow. Some are built in, like agent input topic for the user's first message, and human request topic for when the AI needs to ask the user something. Then they have the specific ones, like user info extract topic after checking the input, hit call topic to trigger asking the user, registers or topic before trying to register, registers respond topic after the attempt, and finally agent output topic for the final reply.
Got it, like dedicated channels.
Right. And then 5 nodes process these messages.
So topics are the lanes, nodes are the processing stations. Let's look at the nodes. What's the first one?
First is an LLM node called user info extract node. It listens to agent input topic, the user's message, and also human request topic if the user provides missing info. Its job is to use an LLM to find the name and email in the input. Then it sends the results founded or still missing something to the user info extract topic.
Okay, makes sense. First step, figure out what the user gave us. What's next?
Next is another LLM node, just called action. This one listens to user info extract topic. Based on what got the name and email or not, it decides what to do next. It sends a message either to hit call topic, need to ask the user, or register user topic. Got everything, let's register. So it's kind of the router directing the flow.
Right, the decision point. Then there's a function tool node, human in the loop. Sounds like this handles talking to the user if info is missing.
Exactly. It listens to hit call topic. Its job is to run a pre-made function tool. They made one called client info with a function request client information. This function takes a description of what's missing and basically generates a prompt to ask the user for it. The output, the question for the user, gets sent back to human request topic. And remember, the user info extract node is listening to that too.
Ah, so it creates a loop.
Right, a loop to chat back and forth until it gets all the details.
Clever. Okay, what about actually signing the user up?
That's another function tool node, register user. It listens to register user topic. It runs another tool, register client, with the function register client. This takes the name and email and simulates putting them in the gym system. Then it sends a confirmation message to register user respond topic.
And the last step, telling the user if it worked.
That's the final node, another LLM node, response to user. Listens to register user respond topic, takes the registration result message, and uses an LLM to write the final response to the user, hopefully confirming sign-up. That final response goes to agent output topic, the standard channel for the assistant's final output.
So it's a really clear flow of info between these separate nodes, all driven by events. They also mention the actual code for those client info and register client tools. Sounds like client info just packages up the what's missing description.
Yeah, basically.
And register client takes the name mail and spits back a confirmation message.
Exactly. They also highlight the system message for the user info extract node. It's really important. It tells the LLM to be a strict validator for full name and email, gives examples, and crucially, tells it not to guess missing details. It's interesting how they steer the LLM so specifically.
The article shows a successful chat, right? User gives info, gets registered, but then they show debugging with a tool called Phoenix. The assistant choked when the user just said, "Hi, how are you today?" What went wrong there?
Yeah, the debugging showed the LLM, the decision maker node, just spat out plain text instead of picking the tool when it got that unexpected question. It wasn't programmed for small talk, basically.
So how'd they fix it? Make it handle random questions better?
They just updated the system prompt for that action LLM, added an instruction. If the user asks something unrelated to registration, use the request client information tool, the same one used for missing info, but use it to generate a polite reply, acknowledging the question, and then steer back to registration.
Ah, clever reuse of an existing tool.
Exactly. And the article shows after the fix, the assistant politely handles, "Hi, how are you?" and guides the user back on track. That little debugging story really shows how observability helps find problems and how flexible Graphite is for tweaking behavior, like just changing an LLM prompt in one node.
Okay, so pulling it all together, Graphite really looks like a solid, structured way to build these very specific AI assistants. It lets you define clear workflows with these modular parts, assistants, nodes, tools, all working together through that robust event system.
Yeah, that's a great way to put it. And it's that event-driven core, with events as the single source of truth,
Hmm.
that really enables those key benefits. Modularity, because parts are loosely connected. Observability, because everything's logged. Idempotency, for reliable retries. Auditability, for that complete history. And restorability, for picking up where you left off.
And for our listener interested in practical AI tools without getting overwhelmed, this look at Graphite gives a really concrete example. Breaking problems down, built-in reliability. It seems like a clear path towards more dependable, effective AI for specific jobs. It really pushes beyond the one-size-fits-all AI idea towards something more well-engineered.
Absolutely. It encourages that deliberate engineered approach for specific needs.
So maybe thinking about your own work, your own challenges. Could a framework like Graphite apply? How could you break down a complex process into those defined steps? It makes you think, doesn't it? About moving past generic AI and exploring the power of custom-built assistants for your specific world. And since Graphite's open source, you can actually go look at the code on GitHub, see how it works. Definitely something worth exploring more.